When installing a UPS to feed existing loads, and needing to refeed some of these loads from the new UPS, there are methods to tap into the existing panel feeds inside the switchgear. First method involves using a tap box. Install a tap box at a suitable location inside the switchgear next to the existing panel feed conduits. Run new conduits from the UPS to the tap box. Connect the UPS feed to the tap box and splice the existing panel feed to the tap box. Seal all conduit openings and connections to maintain the integrity of the switchgear as a raceway. Another method involves using a wire nut. This method should only be used if the existing panel feed conductors are large enough to handle the additional load from the UPS. Disconnect the existing panel feed conductors from the switchgear busbar. Add a wire nut to the existing panel feed conductors and splice the UPS feed conductors into the wire nut. Reconnect the combined conductors to the switchgear busbar. Several National Electrical Code (NEC) sections apply. These include NEC 310.15. B4 concerning wiring methods and panelboards, NEC 300.3. B regarding raceway installations, NEC 110.11 on the use of equipment, and NEC 705.12 concerning emergency and standby power systems. To minimize downtime, thorough pre-planning is essential. Divide the work into phases to avoid complete system shutdowns. Consider using temporary power sources to keep critical loads operating during the work. Test and commission the new UPS system thoroughly before connecting it to the existing loads. To tap into branch panel boards, one method used is a branch circuit tap. Install a branch circuit tap at the branch panel board, next to the desired circuit. Run new conduits from the UPS to the tap. Connect the UPS feed to the tap and splice the existing circuit conductors to the tap. An alternative method uses a wire nut. Disconnect the existing circuit conductors from the branch panel board breaker. Add a wire nut to the existing circuit conductors and splice the UPS feed conductors into the wire nut. Reconnect the combined conductors to the branch panel board breaker. Applicable code sections here include NEC 408.3 on panelboards, NEC 404.2 concerning feeders and branch circuits, and NEC 705.12 regarding emergency and standby power systems. When dealing with tapping into existing panel feeds inside the switchgear, there are primarily two methods to consider: firstly using a tap box and secondly using wire nuts. Let's delve deeper into each method, outlining the steps involved and important considerations. Firstly, let's discuss tapping into existing panel feeds using a tap box. The initial step involves identifying a suitable location within the switchgear to install the tap box. This location should be adjacent to the existing panel feed conduits to minimize the length of conductor runs. Ensure there is sufficient space for the tap box and necessary connections. Next, you'll need to run new conduits from the UPS to the tap box. These conduits will house the conductors that will supply power from the UPS to the existing panel feed. Ensure that the conduits are properly sized and installed according to the NEC. Once the conduits are in place, you can proceed to connect the UPS feed to the tap box. This involves terminating the conductors from the UPS into the tap box, ensuring proper polarity and secure connections. Next, splice the existing panel feed conductors to the tap box. This is where the existing panel feed conductors are connected to the tap box to receive power from the UPS. Use appropriate splicing techniques and connectors to ensure reliable and safe connections. Finally, it's essential to seal all conduit openings and connections to maintain the integrity of the switchgear as a raceway. This helps prevent the ingress of moisture, dust, and other contaminants that could compromise the performance and safety of the electrical system. Moving on to the second method, which involves tapping into existing panel feeds using wire nuts. It's crucial to note that this method should only be used if the existing panel feed conductors are large enough to handle the additional load from the UPS. This is to ensure that the conductors are not overloaded, which could lead to overheating and potential fire hazard. The first step involves disconnecting the existing panel feed conductors from the switchgear busbar. This isolates the panel feed from the main power source, allowing for safe modification of the connections. Next, add a wire nut to the existing panel feed conductors. This provides a means of splicing the UPS feed conductors into the existing circuit. Ensure that the wire nut is properly sized and installed to accommodate the number and size of conductors being joined. Splice the UPS feed conductors into the wire nut. This establishes the electrical connection between the UPS and the existing panel feed. Ensure that the conductors are securely twisted together and that the wire nut is properly tightened to prevent loose connections. Reconnect the combined conductors to the switchgear bus bar. This restores power to the panel feed, allowing it to be supplied by the UPS. Ensure that the connections are properly torqued and secured to prevent overheating and arcing. In addition to these methods, it's important to be aware of the relevant code sections that apply to tapping into existing panel feeds. NEC 310.15 B4 addresses wiring methods in Panelboards, providing guidance on the types of wiring methods that are permitted in these enclosures. NEC 300.3 B covers raceway installations, outlining the requirements for installing raceways to protect conductors from physical damage and environmental factors. NEC 110.11 addresses the use of equipment, specifying that electrical equipment must be used in accordance with its listing and labeling. NEC 705.12 pertains to emergency and standby power systems, providing requirements for the installation and operation of these systems. Furthermore, when undertaking any electrical work, it's essential to prioritize safety. Always to energize circuits before working on them and use appropriate personal protective equipment such as gloves and safety glasses. If you're not comfortable working with electricity, it's best to consult a qualified electrician to perform the work. When it comes to minimizing downtime during the installation process, there are several strategies that can be employed. Pre-planning is essential to minimize downtime during the installation process. This involves carefully assessing the existing electrical system, identifying potential challenges, and developing a detailed plan of action. Phasing the work can help to avoid complete system shutdowns. By breaking the installation process into smaller phases, you can minimize the amount of time that the electrical system is offline. Consider using temporary power sources to keep critical loads operating during the work. This allows essential equipment and systems to continue functioning while the installation is underway. Thorough testing and commissioning of the new UPS system is crucial before connecting it to the existing loads. This ensures that the UPS system is functioning properly and that it will provide reliable backup power in the event of a power outage. When it comes to tapping into branch panel boards, similar methods can be employed to integrate the UPS. Firstly, consider the method of using a branch circuit tap. Begin by installing a branch circuit tap at the branch panel board next to the desired circuit. This provides a convenient point of connection for the UPS feed. Run new conduits from the UPS to the tap. These conduits will house the conductors that will supply power from the UPS to the branch circuit. Connect the UPS feed to the tap, ensuring proper polarity and secure connections. Splice the existing circuit conductors to the tap, establishing the electrical connection between the UPS and the branch circuit. Alternatively, you can use the method of using wire nuts. Disconnect the existing circuit conductors from the branch panel board breaker. This isolates the circuit from the main power source, allowing for safe modification of the connections. Add a wire nut to the existing circuit conductors, providing a means of splicing the UPS feed conductors into the existing circuit. Splice the UPS feed conductors into the wire nut, ensuring that the conductors are securely twisted together and that the wire nut is properly tightened. Reconnect the combined conductors to the branch panel board breaker, restoring power to the circuit and allowing it to be supplied by the UPS. When tapping into branch panel boards, it's important to be aware of the relevant code sections that apply. NEC 408.3 addresses panel boards, providing requirements for their construction, installation, and use. NEC 404.2 concerns feeders and branch circuits, outlining the requirements for these circuits, including conductor sizing of recurrent protection and wiring methods. NEC 705.12 pertains to emergency and standby power systems, providing requirements for the installation and operation of these systems. Remember, safety should always be the top priority when working with electricity. Ensure that circuits are de-energized before working on them and use appropriate personal protective equipment. If you're not comfortable performing the work yourself, consult a qualified electrician. In summary, tapping into existing panel feeds and branch panel boards for UPS integration requires careful planning, attention to detail, and adherence to relevant code sections. By following the methods outlined above and prioritizing safety, you can successfully integrate a UPS into an existing electrical system, providing reliable backup power for critical loads. Additional consideration should be made for load calculations. Conduct a thorough load calculation of the existing panel feeds and branch circuits to ensure that they can handle the additional load from the UPS. This calculation should take into account the continuous and non-continuous loads as well as any potential future loads. If the existing conductors are not adequately sized, they may need to be upgraded to prevent overloading and potential fire hazards. Overcurrent protection is another area of concern. Verify that the overcurrent protection devices such as circuit breakers or fuses are properly sized to protect the conductors and equipment connected to the UPS. The overcurrent protection devices should be sized in accordance with the NEC and should be coordinated with the upstream and downstream protective devices to ensure selective coordination. Grounding and bonding is another area of great importance. Ensure that the UPS is properly grounded and bonded to the building's grounding system. This helps to minimize the risk of electric shock and provides a path for fault current to flow in the event of a ground fault. The grounding and bonding system should be installed in accordance with the NEC and should be regularly inspected to ensure its integrity. Surge protection is also very important. Consider installing surge protection devices, SPDs, at the UPS input and output to protect sensitive electronic equipment from voltage surges and transients. SPD can help to prevent damage to equipment and reduce the risk of downtime. SPD should be selected based on the voltage and current requirements of the system and should be installed in accordance with the manufacturer's instruction. Also be wary of harmonic distortion. UPS systems can generate harmonic distortion, which can negatively impact the performance of other electrical equipment connected to the same system. Consider using harmonic filters or other mitigation techniques to reduce harmonic distortion and improve power quality. Harmonic filters should be selected based on the specific harmonic frequencies present in the system and should be installed in accordance with the manufacturer's instructions. Temperature considerations are often overlooked as well. Ensure that the UPS is installed in a well-ventilated area and that the ambient temperature is within the manufacturer's recommended operating range. Overheating can reduce the lifespan of the UPS and can cause it to malfunction. Consider using cooling fans or other ventilation equipment to maintain a stable temperature. Finally, maintenance is important. Develop a regular maintenance schedule for the UPS, including periodic inspections, testing, and battery replacements. Proper maintenance can help to ensure that the UPS is operating reliably and can extend its lifespan. The maintenance schedule should be based on the manufacturer's recommendations and should be tailored to the specific operating conditions of the system. Another area to note is coordination with utility companies. Coordinate with the local utility company to ensure that the UPS installation complies with their requirements and that it does not interfere with the grid. Some utility companies may require the installation of a transfer switch to prevent backfeeding power into the grid. This is important so that you do not hurt a line worker working on the power lines assuming it is de-energized. Another point is documentation. Maintain detailed documentation of the UPS installation, including wiring diagrams, equipment specifications, and maintenance records. This documentation can be helpful for troubleshooting problems and for planning future upgrades. The documentation should be stored in a safe and accessible location. Training is also very important. Provide training to personnel who will be operating and maintaining the UPS. This training should cover topics such as basic operation troubleshooting and safety procedures. Personnel should be trained on the proper use of personal protective equipment and should be familiar with the hazards associated with working with electricity. Consider the physical security of the unit itself. Protect the UPS from physical damage and unauthorized access. This may involve installing security cameras or other access control measures. The UPS should be located in a secure area that is protected from environmental hazards such as water damage and extreme temperatures. And again, testing and commissioning is important. Perform thorough testing and commissioning of the UPS system after installation to ensure that it is operating properly. This testing should include functional testing, load testing, and battery testing. Any problems that are identified during testing should be corrected before the UPS is put into service. And, to reiterate, make sure to only use qualified personnel. Only qualified and experienced personnel should be involved in the installation, maintenance, and repair of the UPS. Electrical work can be dangerous and should only be performed by individuals who are properly trained and equipped to handle the hazards involved. Consider using a licensed electrical contractor to perform the work. All of these considerations should be carefully evaluated and addressed to ensure a safe, reliable, and code-compliant UPS installation.